All right, welcome everyone. Week 15. We got this week, about 2 weeks after that. So we're actually about a week ahead of schedule, and that's probably because of the lack of midterms this year. Normally, when 41 is in person, we eat up a class doing a midterm, and this class doesn't have midterm, so yay. Instead, we're doing the competency exams. Hopefully, you guys are aware of those things by now. I just put up 2 of them. So we're going to get into the BSTs, and then we'll do hash tables after that. It should be about it. I might do one on inheritance too. Inheritance is it really depends on what company you work for. Some companies go all in on inheritance, and you got to know it or you're not going to get hired. And then some places are like me, and they're like, yeah, maybe. If there's a good use for it, we'll use it. A lot of people don't like them. Inheritance is the base class of evil. It's a famous talk. So, yeah. So there's a lot of hate for inheritance also. Like I said, in the 90s. It was supposed to be taking over the world, this whole object-oriented programming thing, and people get on a hype wagon for things and go all in on it, and then after a while, because the academics, they could just live in their own world. You know, my computer science professor, as far as I know, had never actually worked in industry. Right? It's all too common that I think he was actually in math. At Berkeley. He's a smart guy, and I learned how to program really, quite well from him. He wrote a textbook. Got a couple of his textbooks up here. His name was Walt Savage. And oh, he died. No. Oh, he just died. Oh, sad. I really like the guy. No. But he was a math professor, and then he became a computer science professor. And one of the things that I've noticed is that, like, when people learn things and they go out in the industry, there's like a trial by fire, and like all of your beliefs of like this is how you should do things are like put out there, and then one by one, like, they just start burning in the flames, and kind of what you come through the fires with are like, okay, these are actually really useful, and doing homework projects, like, I give you, and I try to give you different kinds of projects so you get more experience, but it's not really like working at a company, right? Because at a company, you don't start over every week. Like maybe you do. Like, actually, for my business, I wrote a lot of small programs, actually. Fairly similar to this. There were some bigger things that I would work on over the years and add to constantly. But a lot of times, like, because I was a consultant, I would start from scratch, a lot of times. But if you're working for a big company, you work for I don't know, Travelocity or something like that. Like, you're not going to rewrite Travelocity from scratch. You're not going to open up Notepad and go "Hello World," and no, you're gonna sit down, and there's going to be this giant code base, and you're going to have to like get comfortable with it and oriented with it. And there's tools like grep, grep main star.cc. So this is going to search for the word main in all files that end in .cc. And so, like, if I'm searching for where is fraud? Where in this code base do we do fraud reporting? Then you just be like grep fraud. Obviously there isn't any here, but you can use this tool called grep and similar tools to sort of start figuring out where things are in the code base, and that's a completely different skill set. And like I gave you guys a little bit of TDD stuff and testing, but like it's really big for you to like not break Travelocity. You know what I mean? Like, you go to work for Travelocity and you segfault, and now Travelocity goes down. Like, that's more than getting a 0 on a homework assignment. You know what I mean? And that's one of the reasons, like, at the beginning of the semester, students like, well, why don't you give us credit if we, we write a program, but it doesn't work? And it's like, yeah, it's, if your code doesn't compile, it's like, you're not worth anything. Like, if you can't even figure out how to get the code to compile, like, you're just going to get fired. Like, there's not even a point to it. You need to be able to at least get your code into a shape that it can compile. And then on top of that, you have to get your code into a shape where it doesn't like just crash and take out the entire company, you know? And so a big part of that is TDD. And so prior to you being able to have your new code for, I don't know, finding cheap flights or whatever go live, and I have no awareness of how Travelocity did it. I just pulled that website out of my imagination. I have no idea how they do their business. But if it's similar to like how a lot of my friends in the Bay Area do their business, they will have a series of tests and people rubber stamping it and giving approvals and code reviews and things like that. You've seen a couple code reviews in this class, and mine are very positive, right? I just talk about what you did right and how you can improve it and how I would do it and stuff like that, so you get an idea of how an experienced programmer goes about things. But like if you're going to be like submitting, you know, something that's going to go live on Travelocity, they don't want the website to go down. They will go over your code with a fine-tooth comb. They're like, that's a memory leak. Don't do that. You know? And I have videos of code reviews I can post if you guys want to see what they look like in practice. And they're not antagonistic, but they really do want your code to not leak memory and to not crash and take out Microsoft, you know, or something like that. So it's a different experience at big companies. And so what I'm going to teach you guys today is more inheritance. We're going to go over smart pointers, unique pointers. We haven't done that in this class, right? I know I've talked about teaching it. grep pulls up all files of the main.cc file. No. This is going to search for the word main in every file that ends with .cc. Right? So if I'm searching for the word public, you know, I can find every file that has the word public in it, right? So this is what we were working on last time, inheritance.cc. So this is the program. This is the keyword I'm searching for, and that is the set of all files I'm searching within. So star is wildcard, means match all files that end in .cc. And I could also search in all .h files, you know, that kind of stuff. So grep is one of the single most useful Unix utilities for navigating bigger, like everything we've done, it's typically like in one file, like 2 or 3 files. You kind of know where things are, right? Where is my imaginary class found? Oh, it's in imaginary.cc. Okay, it's obvious, you know. Whereas, let's say I go into the easy peasy directory and I want to see where some of these. There's a lot of files in here, right? Like, you know, where am I? You know, where is that bug? You know, and so I could do like grep. I don't know, cn backwards and all the .cc files. There we go. So it's in a file called backwards cn arrows, right? Because that's the pattern that it's matching for, right? A cn with a backward arrows. And so Easy Peasy, for those of you who don't know, is a tool. Won the Best Poster Session Award of CPPCon 2016. It searches for the top 30 mistakes new programmers make. And it was written by students, and so there's a lot of bugs in it, which I should probably fix at some point. But yeah, the bug 14. What is bug 14? I don't know. Bug 14. What is bug 14? Bug potentially undeed. I don't know what that means. Yeah. So that one's not. Yeah. Okay. So yeah, that is a big LS. Yeah. Okay. So we're gonna. So yeah, grep, very useful stuff. We're going to talk more about inheritance today. And to come back to what I was saying, some companies are super big and deep in inheritance. Some of them hate it and refuse to use it. Some of them are sort of in between. If there's a need for it, use it. If not, like I said, I used to really like inheritance, and then I worked in the real world and developed a hatred for it, and then sort of have come back into the middle somewhere as a result of it, just because I saw how unmaintainable it made code bases, and how many just, you know, very hard to debug bugs will come out if, you know, you leave off a virtual or something like that. Then it, uses the base classes function, and a lot of times the base classes function for get health, it's going to be the same for all of them, right? You know, it's going to be the same for all of them, and then one day you're like, you know what, birds should just return, they have less health than they do, so I'm going to override, get health, and have it return health divided by 2, and then you run your game, and it's like, now it's not working. Huh, what's going on here? And you're like, what the hell is going on? And it's because, you forgot a keyword in a completely different thing, and that's why, or a typo here, that'll do it, right? So that'll, even if this was virtual, right? Even if that was virtual, because I have a typo here, it's not going to override the get health on the parent. So that's why you want to use that override keyword like that. It'll throw an error if you're not actually overriding something on the parent. And only virtual member functions can be marked override. So, right, yes, thank you. That, and get health. The const, yes, thank you. Right, exactly. Because if you don't have the const on there, then it's a different function and it doesn't override it. So you gotta be on top of putting that override on, because like I missed that. Like I read this part over here, I didn't look at the const after it, right? And so if you're not very careful, it'll have a different signature and it won't override it. And like I said, in practice, when you've got all these different classes and all this different inheritance, if there's one of the people in the middle that is a bug in it, then that bug percolates through all the other ones. And you have to sit there and like, okay, go up a level, go up into the parent class. No, I don't see anything there. Go into that one's parent class. Okay, it's doing this thing. And you're like scrolling up and down the class hierarchy, trying to find where stuff is actually happening. And, in Java, that's enshrined into law, basically, right? If you want to do anything in Java, it's all classes and subclasses and interfaces and things nested inside of things, nested inside of things. If you want to how to read an int in Java. Buffered reader thing. Scanner, next int, system.in. Yeah, well, that's pretty basic. Let's see, read int in Java from a file. Yeah, so you like nest things inside of things like this. And a lot of times like you'll nest like a buffered reader inside it, and that'll do for, and so it's like inside, all this polymorphism and things like that, and that's just kind of how the language is. Okay, so we're going to talk about more about inheritance today. We're going to talk about smart pointers. So we haven't talked about smart pointers, right? I asked this a second ago. Have we talked about smart pointers yet? Smart pointer, unique pointer. Have we gone over that? Can you guys hear me? Still here? Okay. We talked about it in 45. I don't think we talked about it in 41. Okay. All right. So let's talk about virtual inheritance today and diamond pattern. Okay. So we've got this animal class, and we've got a class. Let's not call it bird. Let's call it flying. So we have flying animals, and they've got some sort of fly method. In reality, it's not going to print I'm flying. It'll maybe move itself in the world differently from other people. That kind of stuff. But it has less health, And so we got a mammal here that it's got hair. Got a squirrel. We got a sponge. SpongeBob is apparently a mammal. Okay. So what if we want to make a bat class? A bat is a mammal that can fly. what do we do? We could do this. We could say class bat inherits from mammal. And we could likewise give it a fly function that will move it around the map using flying movement rather than ground movement. And it could also have half health. Like, do you guys see that? Like we got our flying class up here, and we got our bat class down here. And they're separate because birds aren't mammals. Do you guys know what the problem with doing it this way is? It's kind of two problems. What's the problem with doing it this way? It'll work, I guess. Very good, Emma. Yeah, if we make a change up here in flying, then is the problem with this? No hair. Yeah, so let's say we want to get rid of the health penalty and implement that elsewhere. Then we could, I don't know, comment that out. But now, let's say we forgot to do that in bat. Bats are going to have a health penalty. The flying people aren't. And that's weird, right? So every time you update flying, you have to update bat. And really, these things are just copy-pasted versions of each other, right? Yes, girl.
Elon Musk just did a Gary jump.
Nice. Very cool, girl. So, so what we really want to do is something like this. We want to say bat inherits both from mammal and from flying. Okay. Now, if we do that, we could call fly on multiple base classes of different types. And this, though, is going to present a problem. Okay, so do you guys see what I kind of want to do here? Like, I want to have a bat be both a mammal animal and a flying animal. You guys see kind of the motivation for that? Like, this way we're going to copy out everything from flying into here so that if we ever update flying, then bats will get that update. If we change how the flying physics works or something like that, then bats will inherit it. And the other thing is that if you want to have a function called flyers only, you want to have a function that you can only pass a flying animal to. You can't pass a bat to it. Like if the bat was like this, D3W, you would not be able to pass. You would not be able to pass Batman to this function because it's not actually a flyer. right? You can only pass things that are flyers or inherit from flyers with functions like this, okay? So the trouble with what we've done here is, now, here, let's just switch over to OneNote. So if we've got OneNote 4/19/21. So if we had like a class A and a class B, and then we had a class C that inherits from A and B, then everything inside of here would get copied into the class, and everything inside of here get copied into the class as well. It's not a big deal. It works fine. Okay? So that would be cool. The trouble is, and so if we drew this schematic out, we would draw it something like this. Like you got a base class, and a derived class like this, and C inherits from both A and B. So everything in A gets copied and pasted in, everything in B gets copied and pasted in. Everything's fine. But what if they had two things that had the same name? Ooh. Now it's a bit tricky, huh? It's a bit tricky. You can inherit as many as you want. Yep. Mm-hmm. So let's go back over to Putty. And we'll explain why this thing isn't working in a second. Let me just open up a new file. That's our enum stuff. We don't need it. So let's have class A. Let's do structs. Whatever. Struct A, and it's got integer x, which is equal to 42. Got a struct B, integer y is equal to 420. And then we've got a struct C that inherits from A and B. So if I make let's make that a capital. One of the reasons why I make things capitals is because the standard library doesn't use capitals. And so if they ever add something to the standard library, like they added a byte class, right? And a lot of people had a class called byte, right? They had a lot of people made their own byte class. And then when the standard library updated, it caused all sorts of problems because they were using namespace standard. So one of the reasons why I've literally never been burned by this, I think once it caused a compiler error that took like 2 seconds to fix, is because I follow a standard naming convention that my classes start with a capital letter, and the standard library doesn't do that, so it won't conflict. It's nice. And both class can have the same function in the first class, and this will be the dominant one. Nope. So let's go through this. So let's create a C called who wants the variable named after them? Anyone want to volunteer? All right, Buzikian. All right, Buzikian. All right, and let's give C its. Okay, so if I C out Buzikian.A followed by Buzikian.B followed by Buzikian.C, what do you guys think this is going to print to the screen? No. What do you think this is going to print to the screen? Do I need to add public to A and B? You would think so, right? But when you do inheritance with structs, they inherit by public by default. Classes inherit by private by default. Structs inherit by public by default. Struct life. If you want to save on typing, struct's the way to go. It's not as C++ though. So XYZ values, yeah. So Mr. Wolf has it 42 for 29,000. Yeah. So let's just verify that is indeed what will happen. Okay. Cool. Now, what? What's going to print? Going to print X? Going to print, well, the artist formerly known as Y. What's going to print? Because remember, this is going to copy and paste, right? It's going to copy and paste this line here into C, and it's going to copy and paste this line into C. So which one wins? What do you guys think? So we got one person saying the first one takes precedence, one person saying the second one person saying it won't compile. All three of these are wrong. All three of these are wrong. Yeah, there's a Y in man that doesn't exist anymore. But which one of these? It's compiling. It's compiling. Which one of these is? If I print it out, Bazookian.x, it's got two X's now, right? Which one's a good print? 42 or 420? Which one takes precedence? The answer is neither. Neither does. What happens if you do Bazookian.x, I'll switch this to Bazookian.x also, is that it is ambiguous. It actually will copy and paste both of them. Both of them get copied and pasted over, but you can see it is ambiguous. So, it is ambiguous. However, you can use the scope resolution operator. You guys remember that? You guys know what the scope resolution operator is? Is it because you're redeclaring X? Yeah, we got two X's now, right? So we've got, so C has got two X's, and C++ is like, I don't know which one you want, man. You're saying .x, but you got two of them. It actually will put both of them into the class. And so, yeah, : : exactly. And so you can actually specify which X you want. So I can say A's X, and I can say B's X, like that, and it works fine. Turn off my phone, thank you. Yeah, so if I were to compile this and run it, it gives you the same results as before. This scope resolution operator is very useful. We use it when dealing with static variables. Remember, static variables, static constant, whatever equals whatever. So if you have a static variable, it's not attached to variables of that type. It's attached to the class. It's attached to the class itself. And so you actually access it if I wanted to print Bazookian dot SDHKD, right? That'll work. Interesting. Yeah, you're supposed to do, did I type something wrong here? Static. Okay. This, right? And so the variable is actually attached to the class. So if you want to get constants out of a class, you use the scope resolution operator. It's a static variable. Static variables in the context of classes are attached to the class, not to a variable. It's interesting that the dot operator worked. I wonder if either that changed or I just wasn't aware that that would work before. It's interesting. Okay. We'll let you set SDH. No, it's a constant. You can't change it, right? So, if I made this like a non-const, I could say must be initialized out of line. I see. Yeah. Can you set it equal to x? I don't think so. Yeah. Let's try that. Yeah. Okay. So, yeah, the scope resolution operator is used a lot when you want to say, I'm talking about something in a class, right? Like, I'm accessing Bazooki, and you see the dot there? I'm accessing his A parents X. I'm accessing his B parents X. You guys see that? Does that make sense to you guys? Like, because we've got two X's, so we just need to say which one is which. Hang on, my wife keeps calling me. It's probably important. All right. So, what if we did this? What if we did this? What's going on here? What does our class hierarchy look like now? It's going to look, before we had this, we had C inheriting from A and B. And so everything in A, if A had an X and B had an X, then C is going to have two X's. And you can't, because you have two X's, you can't say dot X anymore. You've got to say A : X or B : X. Not a big deal. But now it looks like this. We've got, switch to the, oh wow, what happened to my fancy pen? There we go. Okay. So now we've got this class C. It inherits everything from A. Everything in A gets put into C. Everything in B gets put into C. But A is inheriting from a grandparent. We call that grandparent for short. So everything inside of grandparent is in A, and B is also inheriting from grandparent. And grandparent's got a variable, let's just call it, I don't know, P, whatever. So if I try printing out Bazookian.p, it won't compile. Why is that? Both of these guys are inheriting from the same class. Isn't that the same variable? Right? No, it's not. The reason for that is because, remember, when you do this, struct A inherits from grandparent, it copies and pastes this into here. And when B inherits from grandparent, it copies and pastes this into here. And so when you inherit from both A and B, it copies and pastes both A : P and B : P into C. And so we would access this like that. And these are actually two different variables, right? I can actually say Bazookian dot A's P is equal to 2001 Space Odyssey, and I can set his B's P equal to 2010. And you'll see they're actually different variables, because this is what it looks like. If A inherits from grandparent and B inherits from grandparent, they're actually copied and pasted. They're two separate sets of variables and functions and everything. You get two sets of grandparent stuff. And that's usually not what you want, right? Usually that's a little weird. You know, if you've got an animal class, right, like we had before, we had an animal class, and that's got like health and damage and stuff like that on it. And the animal class, you've got flying animals, over here that can fly, and you've got mammals over here, and they've got hair. And if you make a bat class that inherits from both of them, you don't want to have two different health variables. You don't want to have two different damage variables, right? Like, that would be really weird. Like, you don't, like, it's just a weird thing to have. And so what you want is for it to look like this. This is called the diamond pattern. You don't want it to look like this, which is what we have right now. Do you guys understand that? Like, right now we've got, like, if we did this with animals, our poor bat would have two different damages and two different healths. Because when you inherit, you just copy and paste all of them, and you copy and paste all of them. And then when you do multiple inheritance, all of them get copied and pasted in, all of them get copied and pasted in. Now you've got two sets of the grandparent stuff. Do you guys see the difference in these two patterns here? Right? I've got two different P's. I've got Buzikian's got a P from his, you know, it's okay. Okay, so he's got 1x from his father, he's got 1x from his mother. Technically the father should be the y, right? So he's got 1x from his father, 1x from his mother, and he's got his own z variable. And so if you ever copy and paste two different things in like that, you have to use the scope resolution operator. That's learning point number 1. So learning point number 1 for today, when doing multiple inheritance, if you have two members with the same name, then you have to use the scope resolution operator, i.e. to disambiguate which one you want. Okay? So we've got two different x's, so we have to say, is this one or is it this one? And then if you have learning point number 2, if you have a common ancestor, then you will get two copies of it, and you disambiguate. Thank you for actually inventing for me the same way. Okay. Now that's usually not, but that's usually not what you want, right? Oops. But that is usually not what you want. All right. So it's a good practice to use the scope resolution operator every time you use a variable during inheritance. No, because usually multiple inheritance is a little bit rare. Like I said, if you get big into these big object-oriented hierarchies, then yeah, you're going to be you'll have like a flying subclass and a land subclass and a swimming subclass. And so if you want your animal to be able to both walk and swim, then your frog class will inherit from flying, or not flying, sorry, swimming and walking. And then those will add 2 modes of movement to the physics engine. And then if you want to have something that can both walk and fly, like a flying squirrel or something, or maybe that's gliding, that's a separate class, you know, so you can glide in. Then you start doing all this multiple inheritance stuff. And then, yeah, you could, but I wouldn't. You should probably design your class hierarchy so that the variables, because you're making it usually yourself. I wouldn't write code like that. You know what I mean? I wouldn't write code like that. This just screams of bad design to me, right? But the trouble is this. The trouble is that if you inherit both from swimming and from walking, both of those are going to inherit from animal. You get 2 copies of all the variables of animal, which is not what you want. And so let me show you guys how to resolve that. There is a keyword called virtual, okay, which is kind of conceptually the same thing as a virtual function. So if you, I'm just like beeping all over the place. I don't know what's going on today. Like I just got a voicemail. My wife's like, I'm getting texts on Discord. I don't know what's going on, dude. All right. Just a popular guy. I don't know what to say. All right. So the virtual keyword for inheritance will allow different subclasses to share a base class. And so, what does that mean? It means we no longer have 2 different P's, or wait, yeah, okay, yeah. We no longer have 2 different P's. We only have 1 now. So father's P and mother's P are now the same thing. Okay. So if we run this, we'll see that rather than getting 2 different variables, we set father's P to 2001, we set mother's P to 2010. Rather than having 2 different variables, we now have 1 variable. When you use the virtual keyword, they share. Like it, rather than duplicating all of the member variables and member functions, they share them. And so that goes from it goes from this model to this model, which is usually what you expect. So if you're having 2 people inherit in a diamond pattern, you need to use the virtual keyword, and that will have your code. Just tag that on. Then you only have 1 member from the grandparent, not a duplicate. And if you inherit from the grandparent 3 ways, like I'm flying and swimming and walking, then you would get 3 copies of damage and 3 copies of health, and that's very rarely actually what you want. So if you're going to go deep in the class hierarchy business, me personally, I would use a variable. I would in fact probably use a bit field. So I would have a variable called physics or whatever, walking mode or whatever, and I would have a bit for like, can it walk, can it swim, can it fly, can it glide, and I would just set those on true or false, and the physics engine would just grab that and be like, all right, well, I'm trying to get to the other side of the cliff over there. It looks like flying is my best bet. I can fly, so I'm going to choose to fly. It's 3 feet away on the ground. I'm not going to fly. That seems a waste. I'm going to walk. Oh, it's under the water. I'm going to swim. And so I would personally use a variable to hold those things. But like I said, a lot of people like that. A lot of people love making classes by compositing different classes together. And that's called an ISA relationship, right? So mother is a grandparent, right? Doesn't make sense, right? Because that's what it means. Mother is a grandparent. Like a flying animal is an animal, right? A bat is a flying animal, right? And so this, I wouldn't name a class this way because a mother is, it's not a grandparent. Like conceptually, it doesn't even make sense. But I'm just naming it this way so that you can see where the variables are coming from. So mother is a grandparent, and mother has a X. So these are the 2 different kinds of relationships in object-oriented programming. You are other classes that you inherit from, and you have member variables inside of you. I prefer has a almost always. And you can also use templates for is chip without inheritance. Right, so you can have a linked list of ints by using templates, right? and people will argue which of these three options is the best. Like when somebody's architecting a new solution, they will. You need to figure this stuff out in advance, because everything you do, like if you're making a game that's got different animals in it, and you need the birds to, I don't know, fly, and the squirrels to glide and walk, and like you need to figure all this out in advance, because if you switch from using inheritance to templates or something, like maybe you templatize the movement types, so like you make an animal that's templated, my class name is squirrel and my movement modes are flying, vertical / walking, vertical / gliding. You can do that as a template, but you'd have to refactor everything you did in the game, right? Like everything that refers to an animal, which in an animal-based game would probably be everything. Your entire physics engine would have to change. Everything would have to be refactored. You'd have to basically start over from scratch. And so you need to figure out which of these three approaches you like the best. And that is something that people will get into very long and tedious arguments about, right? Not so much in real life, but online, the defenders of object-oriented stuff will say it's the best thing since sliced bread, and then I would say, well, sliced bread's not really that great. Have you ever tried freshly baked bread? It's a lot better. So, inheritance seems like a lot of work. Yeah, I don't want to let my biases though influence you guys too much, because you do need to know this, right? Like you saw in the previous Summer Summit, I wasn't doing that to like teach you guys inheritance, where I had the hash table interface, like as a pure virtual interface, right? Where all the member functions were set equal to 0. So you can't actually make a hash table. But I had two subclasses, both of which implemented that interface. And then by using pointers, you could switch out which implementation you have. And I like, this was before I taught inheritance. Like it wasn't, I mean, maybe a little bit. It was kind of like prepping you for it. But I did that because that's how I actually implemented it. You know, just you have a hash table pointer, and then you can say new linear probing mode or new chaining mode, and it just clicks in, and if you call the interface on it, it picks out which one of the ones gets called, and it works fine. It works great. It's a cleaner implementation than if I had to make both a hash table for linear probing and a hash table for chaining. And every time I did a command, I had to say, which mode am I in? I'm in linear probing mode. Okay, go to the linear probing variable and insert. Go to linear probing mode and search. Or go to the chaining mode and insert. Go to the chaining mode and search. And having two variables and wasting all that memory, because I'd have two of them in memory at once. No, inheritance was the right way of doing that, with just an interface and two different people that implement the interface. Yeah, sure, absolutely. But like when people get into these big object like I said, like I'm prejudiced for a reason. I have good reasons for my bias, and like I said, just maintaining these, trying to find where things are gets annoying. Like where, you've got some function that, when an animal bites something, it poisons it. And you look around, there's no poison class that it inherits from. So you're like, okay, where the hell is poison? And you're like, is it in the bat class? No. Go up a level, is it in the flying class? Nope. All right, is it in the mammal class? Nope. Go up to the animal class? Nope. Where the hell is this thing? And you find out that you've got a separate pointer to a damage type class, and that damage type class can inherit from different things. And so then you follow that pointer over there, and you're like going around, like, okay, there's the bite damage type, and okay, that does piercing, but then that subclass composited, okay, there's the poison, and you're just like going through a maze, just trying to find where the damn code is, like it's just like, and like where do things actually happen is actually a really hard question when you're doing inheritance. Like where is the variable, where is health located, is it on animal, is it on damageable animal? And if you're in an IDE, a lot of times you can hover over something and you right click and you're like, go to definition of the variable, and it jumps you into some different file, and it's got like 3 lines in it, and so you have no idea where you are, because you're like looking around like, I don't know how I got here. What relationship does this have to other things? Yeah, just like I said, different enemies instead of one enemy, type of Pokemon, type of Pokemon. Yeah, So you could have a separate subclass for every type of Pokemon, right? You can have a Pokemon class that is a pure virtual class, or maybe it's a class that has the basic stats that all Pokemon have. That could go into the base class. You can have each subclass of Pokemon, one for each one, Pikachu and Raichu and whatever. You could do it that way. Now you've got 151 different classes to maintain. Yeah, right? Like, let's go through and add the ability to, I don't know, add moves to the Pokemon now. I don't know. Like, if there's ever anything you need to do where you've got to, like, add something separately to each of the Pokemon, like, I don't know. You'd have to do it somewhere, all right? Like, somewhere you're going to have to do that work anyway, but, like, having to open up 151 different files, and this is like, you know, refactoring 151 different files. Yeah, I'd rather have one file and have an if statement, you know, because all this stuff with inheritance is just there to avoid an if statement. It's there to avoid having to say, if I am Pikachu, do the Pikachu attack. If I'm Raichu, do the Raichu attack. If I'm Squirtle, do the Squirtle attack. That's what the virtual keyword does for you. The virtual keyword says, figure out what type I am and call the appropriate function. It saves you an if statement. That's it. And so you have to think about, is saving an if statement going to be net beneficial or net detrimental? Because there's a downside to it too. Pros and cons to everything. So, and for an ape inherits from both fire and fighting. Yeah. So you could, but then how do you, so let's say you have, let's say you want to do combat. You want to do the type system Pokemon. Water Pokemon do double damage, or water move does double damage against a fire type Pokemon. So you call a function, and the move itself maybe inherits from water type. Okay, it's a water type move, right? And so you have a function that takes a water type and a fire type, and the inheritance engine will figure out, okay, it's a water move and a fire defender, so it'll call that function, so you'll have something that looks like this, right? You'll have like int damage water fire taking a water move, and a const fire defender. Something like that. All right. And you have to make one of those functions for every combination of attack and move. And then you've got the problem that if you have multiple inheritance, which one do you call? Do you call the damage water fire, or do you call the damage water fighting? Right? Because you got two types on Infernape. So which overload do you call? You know, and so you there's all these, like, they create all these, like, proxies, and all of it is just to avoid an if statement. You know, like, at a certain point, you're just like, just write a table, like a 2D table that just has the type system in it, and don't try to use inheritance to implement a 2D table, essentially, because you're going to make one of these functions for every element on the table, and that's n squared classes or n squared functions, you know. And, yeah, forget about it. You could absolutely do it this way, by the way. It would absolutely work, and it would just be this giant mess. But people that love inheritance are like, yeah, that's the way to do it. You have to use the visitor pattern and the delegates, and it's garbage. It's garbage. Just use a 2D array, 2D vector. Yeah. Type of the attacker, type of the defender. You got two types. Do it again. Grab the multipliers out, multiply them together. Done. Easy. Use a hash table for it. Right? Like in And so this is using it's not a hash table, it's using a binary search tree, either way. And so basically, I have a map set up that maps from strings to which row and column you are in the type table. And so if you pass in poison as the attacker and grass as the defender, it'll go to row 3, column 13, or row 3, column 11, and look up the multiplier there. Easy. So there's just a map that just maps from strings to ints, and so each Pokemon has a string for its type. If I wanted to be even cooler, I could just have it hold the row and column directly in the table, and then that's it. Use an enum for these things, and the enum holds its row / column in the type table, and then you just grab the number. You do a 2D table lookup, or you can make 18 squared functions. Okay, so that is that. That is inheritance. For your homework assignment, remember, don't do inventory, do bit field. I think I've got some cheat sheets here on how you can use macros in Vim. So if you want, do you remember in class last time I showed you how you could like go from like having a bunch of numbers to like turning them into strings and things like that. Q starts recording a macro, like QA starts recording macro A, and then you just insert it, you do a bunch of commands, and when you're done you hit Q again, and then you can replay it with @shift2 @A, and it'll replay all those keystrokes again, and it saves them in between invocations of Vim, and so you can always come back in later. So, and if you do it does the last macro you did again. So if I go that was the last macro. Okay, so you've got all these different constants here, and you're going to need to turn them into strings, right? Because the user is going to type in pick up, the hook, pick up the Navarro, pick up the sniper rifle, and you need to have a string for that. And so using Vim macros to say if the user typed in weapons hook, output 1, and then going the other way around. Yeah, so that macro thing I showed you last time. You're going to need to make a function that translates between a string and the number and the string. And this is your guide using a Vim macro. You can do it pretty quickly. If not, you can do it by hand. A lot of students did it by hand because, I don't know, they think that learning a macro is too much work or something. Would you recommend using an iterator to find the best weapon? Great question. So what I would do actually for the best weapon, right here, select best weapon. What I would do is, it's 64 bits, right? Okay, so I would say while true, 63, okay, so shifty equals 63. I would do this. If, what's in over a bit field? Data field? Data field. If data field bitwise ANDed with 1 left shifted shifty times. So, you take a 1 bit, you left shift it 63 times, that is the 64th bit to the left. That's the high bit. It's the most important bit. If that bit is set, we're done, right? And we would return return it. If not, try the next bit to the right. So start off by sliding that 1 bit all the way to the left. If that bit is set, that's our best weapon. Return it. If not, we decrement shifty by 1, so it goes from 63 to 62. So then it checks almost the most important bit. Then it does, so it slides left a little bit less every time, and then once you hit negative on shifty, then you If you have nothing, it returns throwing a runtime error. Okay. So that's how I do it. Does that make sense, Emma? So you take a bit, just slide it to the left, bitwise and it with the bit field, and that'll tell you if the most significant bit is set. But then you can do that in a for loop, probably cleaner than how I did it right there. And so you just try one less bit every time. You check 10 to the left, 9 to the left, 8 to the left, 7 to the left, 6, 5, 4, 3, 2, 1. And if none of them are set, you should probably do that exception first. Right? So you're guaranteed that there will be a value returned. So that's the cleanest way I can think of doing it. Other people have done it by dividing by 2 over and over again. So if you divide the bit field by 2, then you can figure out when it turns 0. So you divide by 2 over and over. Make a duplicate first. Like, don't modify your data field. Duplicate the data field, and then you can repeatedly divide by 2 until it hits 0. And then the number of times you had to divide by 2 until it hits 0 is which bit was set. 6 of one, half dozen of another. Should only be a couple lines of code. Like most of this is a couple lines of code, and the job. The annoying thing about this assignment is just going from is handling the input. Actually, the bit field stuff. All of them are just a couple lines of code. So it's due on Wednesday. If you guys have trouble with the coding part of it, just please post on the help center. Like I can't emphasize this enough. A lot of people want to go their own way and figure it out on their own, and that's cool. You should try to figure it out on your own. But if you get stuck, all of my best students, ask questions and ask for help. Like Muya has probably asked more questions than any other student in the last 2 years, and he's my TA, and he's really good. It's because he asks questions. Probably good for other reasons as well. No, it's not because he's dumb. It's like, if you don't understand something, what are you going to do? You're going to sit there and not understand it more? Like, give it a shot. Like, really take a crack at it. It's dangerous to just always rely on other people for help, because then you're not exercising your brain. But if you genuinely don't understand something, you need to ask and get unstuck. And for some reason, like, a lot of students just there's Discord. Discord's available 24/7. Like, it's not like like in high school, like, a lot of students just like do it themselves, and high school's really easy. If you waste class time, asking questions, then people might get a little angry at you because you're just taking up valuable. You got 15 minutes and you've taken up 10 minutes of it on a question. It's on Discord, like, you're not wasting my time. You're not wasting. So, it's really important to get into that habit of asking questions. So, you got a good resource. You should take advantage of it. But try it first. See if we can get it to work first. This assignment, the actual amount of code for the bit field stuff is minuscule. The annoying thing about this assignment is the I/O, the input-output stuff. So, how do you handle if the user types in pick up the sniper rifle? How do you actually translate that into a number to add to the bit field? That's the annoying thing, and that was deliberately made annoying because I had to write that code myself. All this code you see in there is actually from my own code, and I've had to write functions to do all that stuff, and I did it using Vim macros. And so I'm exposing you to something that's not quite long enough that you couldn't do it by hand if you had to. If you had to do it by hand, you could do it. You'd be kind of pissed off at me probably and annoyed, but it's also long enough that it's hopefully going to motivate you to learn macros, because macros will save you so much time in your life. So, okay. What was the other thing? Smart pointers, right? Okay. So, all right. Enough praise for Muya. Reel it in, guys. Reel it in. I'm kidding. He's doing a really good job, I think. No, keep it coming. All right, let's talk about smart pointers. Okay, so I've already got one. move main.cc into public multiple inheritance.cc. All right, so then smart printers.cc. Actually, I'm gonna cheat a little bit. So I just gave this talk to my 45 class, so I'm gonna cheat a little bit just so I don't have to look up the header file and things like that. Okay. Sure. Okay. All right. So we got a class up here. It's got like a stack allocated array. Maybe we've got R2. Got a constructor, and the constructor is going to go R2 equals new int square bracket 10,000. All right. So if I were to make a foo, right? What's the problem with this code? Ignore this. Ignore the comments for now. What's going to happen? What's going to happen? I create a variable named bob of type foo. It calls the constructor. The constructor allocates memory. What am I missing? Yeah, it's gonna memory leak. What do I need? What do I need? I need destruct, right? We have this thing called the Recording Artists Institute of America. Wait, no. Our resource acquisition is... And so that's the notion that, allocate in C-stars, deallocate in D-stars. And that applies to things beyond memory as well, right? So foo, delete, and we have to do array delete, not normal delete. Okay, so now we're cool, right? If we had forgotten this, then T++, smart pointers. Do I have address sanitizer turned on? Nope. So it leaks memory silently, right? So if we want to -f sanitize equals address, so we want to turn on address sanitizer. This is aliased for you guys by default. We need to do that. So just so you know, like Emma, you're going to another institution. Take this with you. So you might have seen on the memes channel, it's dangerous to go alone, the Zelda meme. So in my survey of students in my network of spies around the state, none of the C++ professors use address sanitizer. So I'm sure some do, but just the ones my students have taken do not. And so write this down, get it tattooed on your arm, screenshot it, whatever. When you go to a different institution, like at Santa Cruz, they mark you down if you have a memory leak. And they run Valgrind on your tool and stuff like that. But they don't teach people about address sanitizer. Address sanitizer is great, because if you compile it that way, boom, memory leak. It just tells you. And so I just always, when I'm doing development, I'll just have address sanitizer turned on. If I screw something up, it tells you. Really nice. And so it tells you on line 24, You created an object which called the constructor. The constructor on line 12 allocated memory. It was 40,000 bytes, and we leaked it. We didn't deallocate it, right? So, there. You know, do this. There you go. All right. And if we let's put this back in for a second. Okay, we're leaking memory. So if we val grind it, we might have to compile this with debugging. I don't know. Debugging is -G, right? -G turns on debugging information. It's useful if you're going to be using a debugger or other tools. So val grind 8.0. And so val grind is what most institutions use because it's been around since the 80s, and so it's something they know about. Edge sanitizer is only about 5 or 6 years old, so can't expect professors to. Okay, I kid, but not really. But I kid. So, yeah, at some institutions they won't allow you to use modern C++. Can't use C++ 11. It's been out for 10 years. The professor just hasn't learned it yet. Is what it amounts to, you know. No, we want you to learn ANSI C++ because that's the most compatible. Everybody can use ANSI. Yeah. You know, it's neat, like, not having memory leaks, you know, using range-based for loops, like, these techniques and things that cause you to not leak memory and not crash, they're useful, you know, but mark you down if you use modern C++ just because they don't know it. So, yeah, let's turn off address sanitizer. We're using val grind. So when we run val grind on our program, then it does a memory leak and double use and use after free, all these kinds of things. So we've got a leak summary, definitely lost 40K in one block. We had 2 news, we had 1 free. The new and the free you don't see in there because it's invisible. It's behind the scenes. Yeah, so it doesn't tell you what line it's on. So let's try it with leak check full. That. Yeah, doesn't tell you where the line is. I'm sure there's a way of getting it, but I don't know. Address sanitizer is just a lot better. Learn GDB now. Yeah, it's really useful. Okay, so address sanitizer is your friend, and I don't know why they're not teaching it. I literally proposed a talk at CPPCon last year, like, if you're a C++ professor, these are the things you should be teaching your students. Like, use ASAN. It's neat, you know. Just get them in the habit of doing it, then they're going to stop leaking memory and stuff. Okay, so coming back in here to smart pointers.cc. So rather than you could do this. This would work. This is kind of okay. It's kind of okay. It's mostly okay. It's mostly fine. If you only knew things inside of a constructor and you have a matching delete, like, that's probably okay. But like, what about like what we had with our hash table, right? With our hash table in the hash table assignment, we had a pointer and we had a new, and so I had to remember to put the delete at the bottom of the main, and I forgot the first time and I leaked memory. And address sanitizer rightly complained at me. I was like, oh yeah, sorry about that. So if we were doing something like this, and we're going to start doing stuff like this because we're using inheritance, and inheritance, remember last time, inheritance basically requires you to use either a pointer or a reference for it to work properly. And a lot of modern C++ is moving towards no pointers, people who have inherited the fear of pointer phobia from Java, like, they're scared of it, and rightly so, because, you know, there's been a lot of problems over the years due to pointers and memory leaks and double corruptions, and where do I free this memory, right? You know, it's pretty easy to be like, okay, at the bottom of the scope, you know, delete Bob or whatever. But like, what if you have all these different if statements and things like that? You're passing the pointer to a function, and that function's passing it to another function, and there it dies. Then that function needs to know that it's the owner of the pointer and needs to deallocate it, and how do you indicate you're supposed to deallocate it? It gets really, really complicated when you've got a lot of flow of control and you've got raw pointers. This is called a raw pointer, right? The basic built into the language syntax pointer is what we call a raw pointer. And there's nothing wrong with them intrinsically, but they don't indicate if you're supposed to deallocate it or not, right? I could have a function here, void whatever, that takes a foo pointer. And I don't know, I could do stuff with that. R temp points to R, element 42, right? Okay, that works fine, right? The trouble is when you're expecting somebody else to deallocate the memory, and this happens, by the way. You'll pass a pointer to a function, you're expecting that function to deallocate it. Delete temp. We're done with it now. I've transferred ownership of this pointer from main into whatever random keys I hit on the keyboard. There is nothing in the language itself to indicate, is this a pointer? B, is it an array? Because it could be an array. Is it stack allocated? Is it heap allocated? What's the size? I have no idea, right? Because a pointer and array are the same thing. You know, a raw pointer could be used as an array. I can in fact say temp square bracket 0. That would work just fine. Let's see, temp square bracket 0. That would actually work just fine. Hurts my brain to even write that. But the trouble is, like, there's no indication if you're expected to delete it or not. Like, you don't know if you own it or not. And so doing this, where you're passing a raw pointer to a function, the rule is if you get past a raw pointer, assume it is non-owning. In other words, assume you are not responsible for deallocating it. That's just a good rule of thumb to follow. And if you do that, you'll be fine, because then you can pass the pointer to things, and then whoever it was that made the pointer will be responsible for it going away. Now, the trouble is sometimes that doesn't happen, right? Like, it could be created in an interrupt, like the user hit Control C, that allocates the memory. The owner is gone at that point, and the pointer exists and it's floating around. Somebody's got to delete it, and that gets hard. And what the solution has been for years is to just not delete it. The solution is, if you got a pointer like that and you pass it to somebody and they pass it to somebody and they pass it to somebody, the solution is just not to delete it and leak memory, right? And so if we run this code like that, with address sanitizer turned on, then look, we're leaking memory. In fact, we're leaking memory twice, because we nude Bob, and then also Bob nude this, and because Bob's destructor didn't get called, that got leaked also. So we leaked two things, right? But if we're the owner of it, okay, that's cool. Now it works fine. We didn't leak any memory because foo is apparently the owner now of it, and it's responsible for, it's not returning it. You know, if we were to return it, that's one thing, but we're not returning it. So we're responsible for it. We're the owner. We have to take care of it, right? When you're done walking your dog, you have to shoot it. You know, that's the rule. So if we're the owner of temp, we have to deallocate it. But there's nothing in the language itself that indicates if you're the owner or not. And this is a big, big problem. So what happens is that, like, if you're writing this code yourself, it's maybe not as big a deal. But if you are using somebody else's code and it takes a pointer, you don't know if they're going to deallocate that memory or not. You know, and so maybe you deallocate it just in case. But now it's being deallocated twice, right? So we pass Bob to foo and it gets deallocated, and then we deallocate it just to be safe. Nope, crash. Okay, can't deallocate something twice. So this is a pain in the tuchus. So the solution is something called smart pointers. Smart pointers track when they need to go away. And when they need to go away, they call the destructor. And it is nice. And so, for example, this is fine. I'll leave that alone. You could use it there as well. But this is the bigger problem. If you're just making pointers out in main or something like that, that's a much bigger problem. Tracking that is a big problem. So rather than making a foo pointer, which we could also write like that, by the way. You could write it either way. We're going to make a shared pointer. If you're Arthur Dwyer, it is a shared putter. Shared putter Bob. Conversion from foo pointer to shared pointer foo. We could do it like this if we wanted to. Move like that. What am I missing here? Oh, it's foo. Shared pointer foo. Okay, and then this function here is going to take a shared putter of foo and temp. And this no longer works. You can no longer use it as an array because it's not an array. It knows now. The language doesn't know when you pass in a pointer if it's a temp, if temp is a pointer or an array or a pointer to a single variable, or it doesn't know. So now we know it's a pointer, and so you can use it like that, and you can't delete it. The language itself, you can't delete it. The language itself will handle deleting it. Yay. Do you guys see how nice this is? This is Java levels of niceness. Okay, so what we have here is we got a shared pointer. It's pointing to a foo. Basically the same thing as before, and we can use it the same way as before with arrow operator and all that stuff. But there's no delete. So you knew it, you allocate the memory, and then you don't ever have to worry about deallocating it. What happens is that this variable here keeps track of how many copies of itself exist. So when you pass it to Bob, it actually knows that it is a copy of a shared pointer back in main. And so when it goes out of scope here, it does not deallocate itself. When temp goes out of scope here, it simply decrements how many copies of it exist, and it's back down to 1. And so I could still use it down here. I could say Bob points to array 42 equals 1,000. So the syntax of using a shared pointer is identical to that of a pointer. The only line that changes is when you make it. That's it. So before we had this, right? We had foo pointer Bob equals new foo. And we just changed it into a shared pointer pointing to a type of foo. It's the same thing. And the syntax is the same. The function calls are going to change to be shared pointers, but that's good because now the function call tells you it's taking a pointer, not an array. So you know. It also knows you don't own it, and you don't have to delete it anyway. So with a shared pointer, look, there's no delete. There's no delete. It works. 420, 1000. We set it here, we print it here, we set it here, we print it here. It works. Everything works beautifully and magically and nicely. Yay. You guys see that? So if you're in main and you're newing stuff, that's what you want to use. That solves the memory problem in C++. The entire Java language was made because pointers were difficult. And pointers were hard to track who owns memory and when you should allocate and when you should deallocate. Not deallocating twice and making sure the references all get cleaned up. And if you have a pointer to something in a vector somewhere and the thing gets deallocated, the pointer is still pointing at it, so you got a dangling pointer now. Nope, not anymore. Shared pointers. They're brilliant. And the better way of doing it than this, put it back. I'll just copy and paste this. The even better way, the more C++y way, is to use a function called make shared type foo. That's the even better way of doing it. Okay. And so that makes a pointer to foo, and it allocates the memory, and then once it goes out of scope, it's like, no more copies of me exist, bye-bye. And it calls the destructor, and the destructor deallocates the memory here. It's nice. No deletes. You got no news. There's no news anymore, right? You could put a new in there, and it'll work with the new. But what if the new throws an exception? Then bad things could happen. So make shared is the right way of doing it. No news is good news. If you need to new something, use a shared pointer or a unique pointer. Unique pointer is the other option we have. Unique pointer foo named Sydney equals make unique foo. And they're technically slower in runtime. A unique pointer shouldn't have any runtime penalty cost. A shared pointer has a very small runtime cost, because every time you pass it to something, it says, okay, 2 copies of me exist, and then it goes out of scope. Okay, 1 copy of me exists. Then it goes out of scope. No copies. Delete. Right. So the shared pointer has a very small amount of memory and a very small runtime cost. It's pretty much negligible. Unique means shared means you can have copies of it. Unique means only 1 copy exists. And so you can't, for example, do this with a unique pointer, right? If we tried passing Sydney to it, this would be making a copy of Sydney, and it, yeah, can't do it. Won't compile. You cannot make a copy of a unique pointer. Okay. So, you could use stood move. That's how you could transfer ownership to it, but after you do that, then you're not supposed to use Sydney and so that's, what do you guys think? That's it, basically. So with shared pointers, you can pass them to functions and have copies, and they just kind of count. And then when they go out of scope, they deallocate. It's nice. Unique pointers, you can't make a copy, but if I'm done with it in main and I want to transfer ownership over to this function here, I could call stood move, and that will transfer ownership of the unique pointer. So there's no copies. That's the original. And remember we talked about move constructors. That's kind of what's going on. So it steals the internal bits of the unique pointer. So shouldn't we always use shared and then switch to normal pointers when going through and optimizing? No, I wouldn't say that. You have to ask yourself, do I want copies of this pointer to exist? If I do, I use a shared pointer. If I don't, I use a unique pointer. If you're going to have copies of a pointer existing, you're going to need some mechanism of tracking how many copies exist anyway to know when it should go out of scope. So you could, if you really wanted to, replace it with raw pointers, but then how do you know when the last copy's gone? You know, if you've passed, like what if you put a copy into like a vector somewhere? You know, you need to know it's still out there. If you don't keep track of that with raw pointers, you don't know. Does the vector, what if you pop off the thing from the vector? It's gone now. How do you know in main that happened? That could be in a different thread. A different thread could have a vector with a pointer to me. I don't know if that's gone away or not. I have no access to it. And so if you're going to allow copies, just use make shared and don't worry about the runtime cost because it's minimal. It's minimal. Okay. And if you don't want to allow copies, then use make unique. So if I'm going to put a pointer to something in a vector and I'm going to give it to another thread, make unique, transfer the ownership. It's yours now. I don't want to see it again. If I used Sydney here, bad. This is really bad because I've already transferred ownership. Segfault. It's already been deallocated, actually, at this point. What do you want to see? And so we could do the same thing here, but I mean, honestly, this is pretty clean. There's not going to be, there's no real issues from this. You got your new, you got your delete. It's fine. If you wanted, you can make it a shared pointer if you wanted. I wouldn't, or a unique pointer if you wanted. It's fine. So when to use regular pointers? If you just want to have a pointer to something, right? Like if you want to just pass a pointer to something, because a pointer, you know, it's like when you call by reference, right? Call by reference, it just passes a pointer. If you're going to be passing a vector to a function, you want to pass a reference to it, right? Because you're passing the memory address rather than copying the entire thing. And so pointers are the same thing. Like if you just want to pass a pointer to something, it's 64 bits instead of copying the entire object. So it's very common to just pass a pointer to something and just assume it is non-owning, right? That's it. References can't be null. So if you need to have a null option, like there's nothing passed in, use a pointer. Or use an optional class. And there's std variant and std any, and there's also there are ways of getting around inheritance. There's a lot of alternatives to things, but there's nothing wrong with a pointer. The only thing, what makes raw pointers so dangerous is they don't tell you enough information in the type, right? This here tells me everything I need to know. Okay. This here tells me everything I need to know. If I just pass in a raw pointer, I don't know if I'm pointing at a single object. I don't know if I'm pointing at an array. If I'm pointing at an array, how big is the array? I don't know. Am I the owner? Am I supposed to deallocate it when I'm done? Do I not deallocate when I'm done? That's 4 different bits of vagueness if I were to pass a pointer to a foo to a function. So I try to avoid it. But yeah, if you want to poke part 2.reference. Like here, this is something you do with pointers you can't do with normal stuff. So I've got 2 different Pokemon, Pokemon 1, Pokemon 2, and I want to switch off which one's the attacker, which one's the defender. And so I create a pointer for the attacker, and it points at the player 1 Pokemon on one turn, and it points at the player 2 Pokemon on the other turn. They switch. So every turn they switch which one is Pokemon, which Pokemon's the attacker, which Pokemon's the defender. And then my code down here, I don't have to copy and paste my code. I just say, attacker points to, I grab attacker's power and stuff. Attacker points to name and stuff like that. And so just by using pointers, I can switch off which of the 2 Pokemon is the attacker and which one's the defender, without needing to copy variables around or copy and paste my code and stuff like that. So yeah, just there's uses for pointers. They're useful stuff, And I'm not going to make this a shared pointer or a unique pointer because they're not owning any memory. They're just pointing at something. If you're just pointing at something, it's fine. Ownership means you're responsible for the memory allocation and deallocation. And owning pointers are really tricky to do right. And that's, if you have an owning pointer where you're calling new and you're supposed to call delete on it, that's an owning pointer. Don't use raw pointers. Use shared or unique. But here I'm just pointing at something and I'm just switching the pointers around every turn. Works fine. It's a non-owning pointer. It's just pointing at something. It's fine. So, yeah, very useful stuff today, guys. The multiple inheritance, maybe not that useful. Depends on where you work. But copy smart pointer. pointers.cc up into public and make them all public for you guys. So that though, yeah, you want to use those almost always. Inside it, you know, like I said, if you're doing RAII and you've got like a new and a delete in the constructor and destructor, it's probably fine. You know, it's not a big deal. But anytime outside of that, when you're newing stuff, use a smart pointer like 100% of the time, either shared or unique. Is the California Highway Patrol command in an alias? Yeah. California Highway Patrol, it makes my entire public directory public. So rather than making just the file I copied up there public, which takes typing, my computer's fast enough, I just chmod the entire directory. So the entire directory gets republicked. And you notice there's a little bit of a delay, right? Because I'm putting more and more stuff into public. So it used to be instantaneous, but then I put the entire Pokemon database up there. And it takes longer now. That is the ternary operator, yeah. That is saying if it is player 1's turn, then grab the address of player 1's Pokemon. Otherwise, grab the address of player 2's Pokemon. And that's saved into the attacker variable. Remember, pointers are just integers, and so it's just holding the memory address of something. If it is player's 1 turn, then player 2 is the defender. If player 1 turn is false, then attacker is Pokemon 2, and the defender is Pokemon 1. And so by doing this, my code simply refers to the attacker and defender pointers, and at the top of the round, like on the first turn, like maybe we'll flip a coin to figure out who's first, and then the pointers just switch every turn. So at the bottom of the loop, player 1 turn equals not player 1 turn. So if it was player 1's turn before, it's now player 2's turn. If it was player 2's turn before, it's player 1's turn. So if you want Squirtle to fight Mew. No, Mew's not. Oh, move number. Mew. And then there's Squirtle. And there's Mew. You choose a move, like Karate Chop. And so Squirtle just got Karate Chopped, so do double slap. Doesn't do a lot of damage. Pound. Kill the Squirtle. Yeah, so that's called the ternary operator. It's a shortcut for an if-else kind of thing. But it's an expression, so you can actually embed it within other commands, which is really nice. All right, we've gone over already, guys, but good questions there at the end. Take a look at smart pointers. The two things I put up today are going to be in public smartpointers.cc. You take a look at that, and vim public and multiple inheritance, and so you can look at that nonsense right there. Is there a written part to the VST competence exam? Yes, you must be able to traverse a binary search tree. You must write the code for it. You don't have to write the entire class. You have to write a function that will traverse the binary search tree. You have to be able to read code. You have to understand the big O difference for binary search trees. Difference between balanced and unbalanced binary search trees. Is there any way you can macro your input to get to a point in your program? Yeah. Like 50G will take you to line 50, if that's what you were talking about. When running? I don't know what that means. Like macroing input to a program. We did that in the benchmarking, right? Macroed input into a program, right? Okay, so shell scripting, things like that. Yeah. All right, guys, good questions today. If you have any more, ask on the Help Center, and I'm always available for office hours if you guys want to meet up. 11 or 12, Monday through Friday. All right. Peace out, you guys. Have a good one.